Workers made forms from wood and then poured concrete into them. In order to transport concrete to the riverbed bottom more quickly, the engineer invented a dumping device. They just needed to use cranes to lower huge iron buckets containing concrete to the riverbed bottom. Then, workers pulled ropes to open the bottom switch. As the dam took shape, workers removed the wooden forms and discovered a new problem. Cement combined with water generates heat, causing the material to expand. This caused thermal cracks to appear on the dam's surface. Therefore, the engineer cleverly divided the entire dam into many blocks. Then, each mold was about 15 by 15 meters in size. Many steel pipes were also embedded in these concrete blocks. They were used to transport cold water to control the dam temperature. Now the dam has been perfectly connected to the canyon on both sides. The pressure it bears will also be distributed to the canyon on both sides. However, just when they removed the temporary cofferdam for testing, an accident occurred. The dam directly collapsed. After the incident, the engineer discovered that water flowing under the dam would generate enormous uplift force. This caused cracks to appear in the dam and then collapse. To reduce uplift force, he installed many drainage pipes below the dam. He guided the water flow to drain out from downstream. After solving various difficulties, the dam was finally completed. Next came the most critical part, building the power generation facilities. The engineer first built a U-shaped power plant downstream. He installed 17 large turbines and generators inside. Because these machines were too large, he had to figure out a way to transport them to the power plant at the bottom of the dam. Because tower cranes could not complete this task at all. Therefore, the engineer erected multiple cable installations in the canyon. Then, he used pulleys to transport the power generation equipment to the rail cars outside the power plant. Then, trains transported them to different areas for installation. These turbines have many blades, which are wrapped by pipes. When water enters the pipes, it pushes the blades to make the wheel rotate. A generator is connected below the turbine. The rotating turbine drives the generator to produce electricity. These processes seem simple, but in reality, directing water into the turbine is not easy. The engineer had to use explosives to dig a tunnel. He used conveyor belts and other equipment to dig and clear the dirt and rocks. After the tunnel was dug, he reinforced it with concrete. Then, water could be directed into the turbine pipes. However, an accident occurred again. High-speed flowing water generated enormous impact force that washed away the concrete in the tunnel. The engineer had to replace the concrete with steel pipes. He first bent steel plates and then welded them together. After filling the entire tunnel, he still needed to build a special water intake at the pipe entrance. Because traditional drain-style water intakes are easily blocked by debris underwater. Therefore, the engineers specially designed an intake tower with gates. At that time, German spies planned to destroy the dam. They wanted to blow up the intake tower, so debris would go through the pipes into the turbine. This plan was ultimately not implemented. But even if they really blew up one intake tower, it would only destroy one turbine. It would not cause all the turbines to stop operating. Now the power generation